Welcome back to my channel Kishore Sir Ki Pathshala. We are doing chapter Chemical Reaction and Equation 10 Cbse. Last time we have seen how to balance a given chemical equation. Now today we are going to see different type of reactions. First we are going to see how to write the symbols of physical states. Right. So when you see a chemical reaction, okay, is more informative. The physical states of the reactant and the products are mentioned along with their chemical formula. Okay, if I write down a plain chemical reaction, just like this, carbon reacts with oxygen to give me carbon dioxide. Now the reaction is not telling me what are the states of carbon or oxygen or the carbon dioxide. The gaseous, liquid, aqueous and solid state of the reactant and the product are represented by, see here in the bracket, small g, L, AQ for aqueous is written and solid for the solid zone. Now the word aqueous is written if the reactant or the product presents in the solution of water, right, in the solution of water. Now here we were discussing, see, carbon, oxygen and carbon dioxide we have written, right? So if I write here, if S is there, so what it tells us? It tells us that carbon is in solid state. Oxygen G is written, so oxygen is in the gaseous state. Carbon dioxide G is written, so it's in gaseous state. Now you'll see that, take example of hydrogen combines with oxygen to gives me water. See here, hydrogen is in gaseous state, oxygen is in gaseous state, and water which is formed is in liquid state, right? Now here you'll see that, let us take example of this, iron reacts with water. Now you will find here that we have written water here as liquid, right? And here you'll see that it is G for the gaseous. So there will be a confusion why we have written here L and why we have written here G. This is because water here indicates that it is in a steam form, right? It is in a steam form. So we have written G here, right? Then hydrogen is formed, it is in the gaseous form. In some of the reactions where we need to write down the temperature, pressure or the catalyst, the reactions are indicated above or below the arrow. Here you see the temperature has been, pressure has been required. So 340 atmospheric pressure. So we have written here above the arrow. So this information is provided below or above the arrow. So writing this physical states gives us more information about the given reaction. Now there are many different type of reactions what we see. So the first reaction is a combination reaction, right? The reactions which happens. So there are many type of reactions. So let us see the first one, which is a combination reaction. Now what is this combination reaction? So combination reaction is nothing but in this reaction what is happening? A single product is formed from two or more reactants. For example, two or more reactants I have got, right? A single product will be formed, right? A single product is formed with two or more reactant. Product will be, a single product will be formed. Let us take an example of calcium oxide, right? Calcium oxide is reacting with water. Calcium oxide reacts with water to give calcium hydroxide, right? Calcium oxide, we should always remember that it is called as quicklime. Calcium oxide is called as quicklime. Okay, reacts with water, okay, and we get slag line. If you take a beaker, take calcium oxide into that, put water into that, right? You will get what? We will get calcium hydroxide, right? Now this is in what? it is formed in water. So we have written its state as aqueous. Okay, so this is called as slaked lime. Along with that, heat is generated. We'll discuss about the heat which is being generated, right? So heat we are not considering as a product. So the product is single. Which is the single product? The product is only slaked lime. So I have got two reactants here, that is calcium oxide and water, and I'm getting a single product, that is the slaked lime. So in this reaction, calcium oxide and water combine to form a single product, that is calcium hydroxide. Such a reaction in which a single product is formed from two or more reactant is known as combination reaction. So this is the definition of combination reaction. Now let us see the example of calcium hydroxide, right? Okay, which we use for whitewashing walls. Okay, now calcium hydroxide we have seen earlier. We have seen calcium hydroxide how it is formed. So what we have done, we have taken calcium oxide and then we have put it in water, right? And we got what? We get calcium hydroxide. Okay, see that we have seen here. Okay, to get calcium hydroxide, right? Now this calcium hydroxide, okay, is used for whitewashing walls. Now calcium hydroxide, what it does, it slowly reacts with carbon dioxide present in air. Okay, you apply a layer of calcium hydroxide on the wall, then what will happen? It will slowly react with the carbon dioxide present, okay, in the atmosphere, and a thin layer of calcium carbonate is formed, okay, which is insoluble, that is formed on the walls. Now the calcium carbonate, okay, formed after 2-3 days of the whitewashing gives a what? It gives a very shiny finish. It gives a shiny finish to the walls. Okay, and to tell you, the chemical formula of marble is also calcium carbonate, right? Okay, so this is the answer for this whitewash which is being used, okay, which gives a shiny appearance. Now the combination reaction is not only that only two elements are reacting, right? Only two elements are involved and they are reacting. Like here you see that nitrogen reacts with hydrogen to give ammonia, right? So what is involved? Nitrogen element and hydrogen element involved. Here iron reacts with sulfur, right? Okay, so it's not like that only two elements are involved. In this what we see is that you can have two compounds can also react. So sulfur trioxide reacts with water to give me sulfuric acid, right? Or you can find out that one single element can react with a compound. Here you see oxygen reacts with carbon monoxide to give carbon dioxide, or two compounds they can react together, that is ammonia reacts with hydrogen chloride gas to give ammonium chloride. Okay, so we need to remember that when two or more substances that can be elements or compounds, they combine to form a single product, right? The reactions are called as combination reaction. So a question can become coming is that give an example where both the elements they react. Okay, so in that time you need to give such an example. And if the question comes, give an example where one compound and one element reacts, then what? So that time the examples will be very specific to answer. Now let's see what we understand by exothermic reaction. If you see in the previous slides, we have seen that calcium oxide, it reacts with water to form calcium hydroxide. Okay, so the calcium oxide was there, so that reacted with water, and we got what? We got calcium hydroxide. Okay, that was the product. Along with that, we got heat. Now, how this heat we got? If you see in the beaker, we have taken calcium oxide. The moment you start adding water, what will happen? If you touch the beaker from outside, you will see that it has become little warm, right? The temperature has increased. Okay, so what it indicates? It indicates that a large amount of heat is evolved, and that makes the apparatus warm. The reaction in which heat is released along with the formation of the product are called as exothermic reaction. So this is the definition for exothermic reaction. Okay, where heat is being released. Now let's see, is respiration is an exothermic process? Okay, what we feel about that? Let's try to understand. Respiration is an exothermic process because it releases heat and energy. Okay, so that we need to remember, it is an exothermic process. Now let's see the explanation for that. To stay alive, what we need, we require energy, that we get it from the food that we eat, right? So now what happens during digestion? During digestion, food is broken down into simpler substance. The food is broken down into simpler substance. For example, the rice, bread, what we eat, right, which contains carbohydrate. So these carbohydrates are broken down into glucose, right? This glucose combines with oxygen in the cell and it provides us the energy, right? Okay, it provides energy and the energy is given out. So the special name of this reaction is the respiration, right? So what you see is that respiration is an exothermic process. Now let's see the vegetable matter which decomposes, right? We are going to see a reaction called as decomposition. Let us take an example only for exothermic reaction in this case. The decomposition of vegetable matter into the compost is an example of exothermic reaction, what it says. Alright. Okay. So let's try to understand what it's all about. In the case of decomposition of vegetable matter, what happens is that when microbes reacts on animal or plant waste, okay, or the food material, then what happens? A lot of energy is given out, which leads to the release of gases, thus terming the reaction as exothermic reaction. So a lot of energy is given out during this process when these microbes react on the animal or the plant waste or the food material waste. Okay, so we need to remember this. So students, I'm sure you have understood today's topic of combination reaction and few examples regarding that. So kindly share, like and subscribe my channel Kishore Sir Ki Pathshala.